All right. Okay, so we got our recording going and everyone should hopefully be able to see my slides. Ed and I are very excited to be offering this information to you today, and we're going to kick things off right away by covering why we should be worried about contamination. If you take a look at the photo in the top left of the screen, if a bale of cotton were to show up in a textile mill with any of those contaminated materials in it, it's going to be a problem for them. As it goes through the fiber processing and goes into carding, all those contaminants have the potential to be broken down into smaller and smaller pieces, and they're going to begin to act as textile fibers. And when that happens, you have the real probability of a contaminant being incorporated into the structure of a yarn and then ending up as a defect in a fabric. When that happens, you're going to potentially get a rejection of the goods for sale. You may have a claim brought against your company, and you very well could lose a valued customer. We are all aware of the challenges that we've had with plastic contamination on our classing calls. And if you look at the graphic on the right, you'll see that even most recently from the current season, it's still predominantly the round module wrap that we're finding in the classing samples. If we add together the colors of the yellow, the pink, and now the blue, that's 89% of what's been found in classing this season. The second most prevalent thing behind round module wrap is going to be that black agricultural plastic mulch that we have, which has been an issue long before we had challenges with round module wrap. Now, we consider this to be a serious threat to the reputation and value of U.S. cotton, which is why Cotton Incorporated has invested funding in all three of our research divisions to work on contamination. And this is just an example of one area of research, just in ginning, where you can see that we have activities in fiber competition that I'll be sharing with you today, activities in our agricultural and environmental research group, which you'll hear from Ed. There are many areas where we overlap and cross-collaborate, such as some of the camera systems. In addition to that, we get significant support from the fiber processing group, as well as all of product development and implementation in supporting a variety of the research activities that we are funding, as well as doing internal research as well. In addition to that, members of all three divisions cross-collaborate on efforts such as assessing the properties of cotton bale bagging. And you'll also hear from Ed today about efforts that we've done on a round module wrap standard. We're going to take you on a journey. We're going to stick Ed in the field. He's going to tell you about everything he's doing for contamination efforts and robotics in the field. He'll take you all the way up to the module feeder, where he'll then turn things back over to me. I'll carry you through the rest of the gin and then take you into a textile spinning mill. So with that, I'm turning it over to Ed to talk to us about his research efforts.
Hey, thanks, Vicki. So we will start in the field. And we will throw in a little bit of robots here at some point, but I'll talk about really, I try not to use the R word, which is robot. I really should use the word automation and really some of these advanced technologies. And you'll see throughout this presentation, machine vision is playing a big role in that. One of the things we've been doing for about the last 3 years is we've put cameras on some module handlers in the field, in the gin yard, and at the module feeder to really see where some of these modules are being damaged and what are some of the most common occurrences. And so this has been a collaborative effort. You can see listed there, Jason Ward at NC State, Bobby Harden at Texas A&M, and John Monure at the Lubbock Gin Lab. And so we've summarized some of those findings that you can find in a report on cotton cultivated. If you go there and just search harvest, it'd be one of the reports that comes up. But what we've seen are things that you'd expect. We've seen damage from module trucks, from the chains not being synchronized, from poor alignment in the field and the sidewalls hitting the modules. Also, when we see people using loaders that sometimes when they back the forklift up, they turn too soon and clip the edge. So there are some, and not picking them up high enough when they set them on the flatbed and causing some tears there. So there's, we really want to encourage people to be careful in handling these modules all the way from the field to the gin. And we've captured some of this in the next slide where we talk about our educational efforts. And so this has been really a collaborative effort. The National Cotton Council has really been leading our contamination prevention education there in the bottom left. And this is also linked on Cotton Cultivated. They've done a great video series on the prevention of plastic contamination, again, looking at everything from settings on the harvester all the way through how the gin can better handle these modules at the module feeder. Also on our focus on cotton, Vikki's given a great presentation on, going into more detail what the textile mill, why it's important to the textile mill that we keep contamination out of cotton. And there you can see that report that I mentioned pictured, as well as some ideas all the way back to when Tommy Valco was still in business, and is still relevant on how to handle those round modules. So I just wanted to point out that it's not just technology, it's education that we need to make sure all our employees are properly educated on the importance of taking care of these modules. And if we look at the next slide, you'll see this is where we've got 3 seasons of data now and a lot of images. And what we've done so far is graduate students have had the joy of going through these thousands of images and trying to pick out the ones where there's damage. And so right now, Bobby's at Hardin at Texas A&M has a student training a machine vision system to automate that process. So we've got that intermediary report out. And so we want to finalize that report. We'll probably get 1 more year's worth of data actually this year, but so we can really pin down where are those biggest issues that we need to be watching out for. All right, so if we move on to the next slide, the other thing that Vikki alluded to, it's been a corporate, all our research divisions at Cotton Incorporated have been working on a performance standard for module covers. And some of you, I think these orange ones showed up out in West Texas, and they had a lot of problems. And they, the Tama is the company that has produced these wraps for John Deere, and they have the only, approved wrap by John Deere. And so we have developed, what we're concerned about is some of their patents will be running out in 2023. And we don't want to see that picture on the left. We want to make sure that all the wrap that's used is of good integrity. And because we know that wrap failure or wrap damage is one of the main ways this contamination is getting into the gin. What is the real cost of a cheap wrap? Think about how much effort it takes to clean up. Think of how much discount you can get if plastic is a call on one of your bells. And also, many of you are aware of the new John Deere 770s are out there. They are capable of making a larger diameter wrap, and all the ginners in here will appreciate, want me to emphasize, just because you can make a 96-inch diameter wrap module doesn't mean you should. And so you really need to check with your gin, even if you're hauling on a flatbed, need to make sure that their module feeder is able to handle that increased size. Otherwise, you're just going to create, a real mess for yourself and for the gin. So please do keep that in mind with this new capability coming on with the new machines. And going back to on the next slide where we'll talk about this module cover performance standard, this has again been a collaborative effort across every research division at Cotton Incorporated. Vikki's lab, Suzanne Holmes and her lab has really helped us a lot on test methods. Mary Ankeny in our product development division has some experience with plastics in her past, so she's helped. We've been led by Dr. John Wanyura at the Lubbock Gin Lab. Then there's been university folks on this American Society of Biological and Agricultural Engineering Committee that have been involved in this process, as well as Tama and John Deere. So this has been a real group effort to try to come up with a set of laboratory tests and field tests that define what is an appropriate module cover performance. And so we think this is we just finished this up It's been through, it's passed the first round of voting. There's some formal steps. This will not only be an ASABE, but it'll also be an ANSI standard. So there's a couple more steps in the formal standards process, but essentially this is now an approved standard. And I know that the National Cotton Council and National Cotton Genders are thinking about, how we're going to implement this. But I think one of the ideas right now is that the council will keep a list of approved wraps and manufacturers. But I think it's just going to be real important in the future that if you don't use if there's some competition to the Tama wrap that it meets the standard, you won't want to use it otherwise. So with that, we'll move on from the discussion of standards and get into more into the robotics part. So I didn't want you to feel cheated that we didn't have some robotics. So many of you are very familiar with UAVs. We've been using them to scout cotton. We've been using them in our research for high throughput phenotyping. And also there's been a small project by the USDA ARS Gen Lab in Stoneville, Mississippi, where they've been using these to scout for plastic in the field. And they're just trying to optimize, what's the highest you can fly the UAV and still be able to detect the plastic. And there's really two reasons we're doing this. One is to as a research project, to really look at where is plastics most frequently going to occur so that we could advise you. And I think many of you already know this, but it's going to be near highways, near population centers. Probably the field on the back 40 is not worried about that. But what I do envision in the future is, you can see this robot or this UAV on the right has claws on it, and that's commercially out there. If you have someone that's providing a service for scouting with UAVs during the growing season, this might be an added service they could provide at the time of defoliation for those fields where you could have a plastic problem. I know I've talked to some of our board members before about looking for plastic, and some of you have told me, there's just 3 of us and we got 2,000 acres or whatever. I don't have time to chase plastic bags, and so this might be a way to chase those bags. And if we look at the next slide, we'll get into full-on robotics here. This video that's running in the left is an example of where we're at on a automated harvest system. This is testing what they call the end effector, basically that claw on the end. You can see it's getting pretty good at removing the cotton from the boll. And that is a machine vision controlled system. You see right there, that's the computer's controlling that arm as it's being evaluated. And we've been also working with the University of Georgia. Glenn Rains has a group, and they've been testing on a spider sprayer. Now they've downscaled that to a rabbit tractor. And, in the future, if we have a more intelligent, even if it's not a little robot running between the rows, that's still a possibility, but maybe we could make an intelligent header that's smart enough to only pull in cotton and not plastic. And so I'll come to my last slide and just talk once we get it out of the field, and it enters the gen. We do have a lot of efforts, working with gens to put in cameras just to monitor it so they know if something gets on the feeder apron and the dispersal cylinders of the module feeder. And there's a project with Texas A&M supported by the Texas State Support Committee to see if we can automate the removal of that plastic when it wraps around the cylinders. And so they've been devising an automated system to remove the plastic using a series of stainless steel brushes. And that's looking to show some promise so that when you do get that plastic on there, you can really limit the downtime at the gen, and so you can get back in business as quick as possible. And so now I've got you to the gen. I'm going to turn it back to Vikki to take you on through the supply chain.
Thank you, Ed. Everyone, let me introduce you to the golden line. And as I talk, please take a look at the video in the upper right. Periodically, you'll see yellow plastic being trapped on that cylinder that's spinning around. This is a system that we imported several years ago because of the interest in this large air chamber, with the idea that the heavier seed cotton would separate out from the lighter weight plastics and create a mechanical separation in this manner. Now, unfortunately, it doesn't perform as we had hoped it would. It is better when we compare it to stick and cylinder cleaners in terms of removing plastic, and I would say it's fairly equal in terms of removing natural trash. However, it does struggle with a heavier weight round module wrap, and it kicks out a lot of good seed cotton, which is problematic. The efficiencies would have to be much higher to justify what we're seeing in this machine. The researchers at the New Mexico Gen Lab did attempt several different modifications in an effort to try to improve the efficiency of removal and minimize the amount of seed cotton. And unfortunately, those efforts were not successful enough to justify the footprint and the cost of this machine being recommended for a US Gen. But we learned a lot from this, and the researchers have several ideas based on the mechanics and the dynamics occurring in the system that might lead to the potential of doing some modifications to our existing equipment in US Gens to amplify cleaning ability. We're moving forward now into color imaging analysis at the Gen stand. You have several systems here on the screen. We're going to start with the upper left. This is the Viper. I have spelled out the acronyms for you in the text on the screen if you're curious as to what it stands for. The Viper is trademarked and is now property of the Lummus Corporation. And this effort has been several years in progress with the Lubbock Gen Lab group. The results from the beta trials are presented to you in the graphic on the bottom left. This is a color camera system, series of cameras and air ejectors on it that's housed right above the apron feeder of the Gen stand. So as an image of colors detected, a puff of air ejects that plastic from out of the Gen before it goes into the Gen stand. Very efficient at removal of bright colors. Nicely done with the yellow and the green, certainly does better with blue. It's easier to see against the yellow. The image that you see in the middle, after the beta trials, the Gen that participated in the beta trials did continue to maintain and run the Viper units on their Gen stands, and were kind enough to share a photo with us after their Gen season showing many of the materials that were caught by the Viper system that could have ended up in the bales at that Gen. On the far right, we have what's known as the Viper Lite, which we're calling the Vision system. Whereas the Viper is a series of color cameras and air ejection, the Vision is a camera system only, is a detection system only, with the idea that something like the Vision could potentially lead to real-time monitoring. The image that I'm showing here on the screen is where we have Vision on 6 different Gen stands, and those images are being captured and shared to the Gen manager's computer. And these have timestamps, so we know when the instance occurred. The challenge that we have with this is it's capturing a lot of images. There are times where we don't necessarily want to capture images, and we have to figure out how to reduce the burden on the computer memory in terms of when to call and purge those imaging systems. But these type of capabilities, while we're currently doing it at the Gen stand from a research perspective, leads to the potential of one day being able to have real-time monitoring at virtually any place within the Gen for watching contamination challenges. The next generation of Viper, Viper trademark belonged to Lummus. USDA work has still continued. The Lubbock Gen Lab has continued to progress the next generation of features. We are calling this the Plastic Inspection Detection Ejection System, or PIDES. And our challenge has been to go after the colors that the Viper system is not capable of detecting. The Viper does really well with the bright colors of the round module wrap, but it doesn't discern as easily things such as black, grays, browns, whites, and clear plastics. And since black plastic is the most prevalent issue after round module wrap, that has been our goal for moving forward with this technology. But it's not easy. If you take a look at the images in the middle of the screen, those little blue boxes, the fine details of discerning the difference between black and the browns and grays of natural cotton trash is very challenging. It's a tiny little part of the luminescent scale that we're able to look into. But the images on the right, you can see that they have developed classifiers that are capable of discerning both black plastic as well as the black nonwoven agricultural mulch. This does take more processing time. And there's also some modifications done to amplify the capability to achieve these detections. So it's not 100%, and there's still a lot more work to be done. They have collected over 5,000 images to help build the classifiers for this. And they're also beginning to look at the idea of texture classifiers, where color isn't necessarily going to be as important going forward. And moving beyond color, I'm pleased to say that we have just initiated a brand new project using ultrasonic sensors where color doesn't matter at all when we're looking at this system. On the left, you see essentially the receiver and the transmitter. There's a platform with cotton and plastic in the center. And then on the right, you see the graphics that we do get very different amplifications when it's just cotton versus when there is plastic present in that cotton. First question we had about ultrasonic sensors is how on earth will they behave in a ginning environment? So we did have the opportunity for these researchers from Texas Tech to take a simple tabletop version of the system and set it up near a gin stand for several hours during the ginning season. And we were pleased to see that neither the vibrations or the noise coming from the gin had any impact on the capabilities of collecting a signal from these ultrasonic sensors. So that proof of concept has been shown. This is a brand new project that has just been launched, and they have a lot of work ahead of them in terms of building an electronic ultrasonic array and proving that it actually can consistently detect a variety of plastic materials. With this, we're going to transition and wrap up in textiles. What you see on the screen here are a variety of different contamination detection systems that are available within fiber processing as well as in the yarn detection capabilities of a textile spinning mill. The systems that you see, some of them are very new, but the concepts and some of these technologies have been available since the late 1990s. And the first question I'm often asked is, if we can do this in a textile mill, why can't we just use the same technology in a gin? Well, the fact of the matter is these systems work fairly good when you're working with clean bale lint at the low volume and the low speeds of processing that occur in textiles versus dealing with seed cotton and all the natural contamination that we have at extensively higher volumes and much faster speeds that are occurring in a gin. So it's not an easy adaptation for moving these technologies into the gin environment. The next question that might be asked is, well, if these technologies are available in the textile mill, why don't the textile mills just clean up the problem? Why should we worry about how much contamination is actually in the bale? Wrong. This is all about the perception and the value of U.S. cotton. But additionally, these are not inexpensive systems. This is a burden and a significant cost to a textile mill to put these systems in. We traditionally have only seen larger volume international mills that are updating their facilities or building new facilities that are more likely to invest in these technologies. And they are not perfect. They do not get 100% of the contamination out, which we have seen directly in our own fiber processing lab at Cotton Incorporated. The image on the top left is that brand new Tusler TS-T5 contamination system that we were able to obtain and install in the last year, and has already gone a long way to supporting a variety of research projects for Ed Barnes as well as myself. It was used to evaluate the 11 bales from the 2020 Viper commercial beta trials. In the 2019 trials, those bales had to be sent to Germany to go through a contamination detection system. The 2021s, those 11 bales were processed, and you see the images on the screen there of the materials that were collected out of those bales. We knew how much plastic should have been in those bales after the Viper trial. The system only caught 66% of what we had hoped to catch out of those bales. So that means if those 11 bales had made it to a textile mill, there still was likely going to be contamination that even the best detection systems at a textile mill wouldn't be able to capture and potentially end up as a defect in their yarns and products. So we've got a lot of efforts underway that we've shared with you today. Ed and I thank you very much for joining us this morning. And at this point, we will open things up to questions.
Thanks, Vicki. I think Shelley's going to take over the questions.
Good morning, everybody. If you have